Welcome back. So directly we can start a program, timer program. We'll see how to write the program for a particular statement. So let's consider this a program. Write a program to generate 50 hertz square wave form on P1.1. Use timer 0 in mode 1 to generate frequency. Assume XTAL is 11.0592 megahertz. So this is the question. The question is given. So write a program to generate 50 Hz square waveform on P1.1. So to generate this, use timer 0 in mode 1. Assume the oscillator frequency. XTAL is nothing but the oscillator frequency. The oscillator frequency is given 1.0592. And again, you see the question. In the question, you find any frequency information or time information. Say you generate this frequency, generate this much delay. Then you supposed to make use of timer. Of course, using instruction also you can able to write a program. But if you use timer, then you can able to generate the required frequency. In the last lecture, we have discussed the basic functionality of the timer. What is timer and the modes of the timers and the operation of the timer. And in this question, it is given use timer 0 in mode 1 to generate the frequency. Say first we'll see how to select timer 0 in mode 1. So can you remember there are registers is called a T mod and Tcon. Two registers we have discussed in last class. It is called T mod and Tcon. And the T mod register is used to configure modes, and the Tcon register is used to start or stop the timer and to check the overflow rate. So we'll discuss. And in this problem statement, you are going to use mode 1, timer 0 in mode 1. This is given. And to select this, you're supposed to use register Tmod. What is Tmod register? This is one 8-bit register, and the register is not bit addressable. This you don't forget. And the register has 4 bits, 2 sets of 4 bits, and the same 4 bits is also available for both the timer. See, the lower 4 bits is used to configure timer 0, and higher 4 bits is used to configure timer 1. So this we have seen last class, the last lecture. In question, you are asked to use mode 1, timer 0 in mode 1. So timer 1 is not required. So the value of timer 1 is don't care. And we are going to use timer 0. In timer 0, what is role of gate bit? If the gate bit is 0, using instruction you can start or stop the timer. It's not a stop, sorry. You can start the timer. If the gate bit is 1, along with instruction you need to apply some external pulse. But here in question, no such cases are given. So the question is very simple. You are going to generate a square waveform. For that, you are going to use only this timer 0 and mode. Only this is given. So it is not a conditional start. So you can make the gate bit equal to 0. What is role of this bit? C/T bar. If the bit is 0, the hardware becomes timer. If the bit is 1, the hardware becomes counter. So please remember, in 8051 microcontroller, you have only one hardware can configure this hardware either timer or counter by by writing value in the bits. And again, the last two bit M1 and M0 is used to decide the modes, and 00 for mode 0, and we are going to use mode 1. So these two bit values are 0 1. For mode 2 it is 1 0, for mode 3 it is 1 1. But we are going to use only mode 1, so it is 0 1, and 001 is nothing but 1, and these values are don't care. We are not going to use timer 1. So by default we can assume all don't care values are 0, so the tmod value will be 01h. Since the tmod is not a bit addressable register, you are supposed to write 8-bit value into the tmod register. This is very important because it is not bit addressable. It is not bit addressable. So always you should write this number 01 into the tmod register. Clear? If you have doubt, you can ask. And again, before start the program, I list out the algorithm, the steps to be followed for any timer or counter program. The first step is you configure tmod register. This we have done. You configure tmod register. And step 2, load or identify initial value. This we are going to do it now. And step 3, you start timer. And once you start timer, you wait for overflow. Once overflow bit is set, stop timer and clear overflow bit. Then you take complement or set or clear any port, because through port only you are going to generate the square waveform or delay. And you go to, or I'll write reload initial value, or go to step 2 if necessary or if required. And for any timer program, you are going to use only these 8 steps. That's all. If you remember these 8 steps, then you can able to write any timer program. And the configuration of tmod register is already done. For the given problem statement, we used timer 0 mode 1 to generate the square waveform, and for that the tmod value will be 01h, and this value we have calculated just now. And the remaining steps are, we see remaining steps how to do. And step 2, load initial value. We see how to load initial value. In the problem statement, you are going to generate the square waveform, and the frequency is given, and the frequency of the square waveform is 50 Hz. So if frequency is 50 Hz, what is duration of one tick? No, the time is nothing but 1 by f. Okay, this is nothing but 1 by 50 Hz. What is 1 by 50? 1 upon 50 is 0.02 seconds. So the duration of one square waveform between two rising edge or between two falling edge, if we measure the frequency between two rising edge or between two falling edge, the total duration of the square waveform will be 0.02 seconds. So this is the total time. Now what is square waveform? The square waveform, all square waveform are 50% duty cycle waveform. Means I can say on time is equal to off time. So what is on time? This is the total time. If you want to find the on time of for the particular square waveform, you're supposed to divide this number by 2. So you will get 0.01 seconds. So and again you are going to generate the square waveform. Again go back, you will see the question. You are going to generate the square waveform on P1.1. So come to this. If you complement P1.1, if you complement P1.1, every 0.01 second, you will get the duration of one pulse will be 0.02 second. If you convert this time equal to frequency, the frequency will be 50 Hz. It is clear? Again, I repeat. If you complement P1.1, because you are going to generate the square waveform on P1.1, if you complement P1.1, every 0.01 second, the total duration of the second, say you are going to complement this pin every 0.01 second. So if we measure the time duration of one pulse, it will be 0.02 seconds. Again, if you convert this time to frequency, and again this frequency will be 50 Hz. And this is the frequency you are supposed to generate. It's clear? So here the required time delay will be 0.01 second. Or this is the required time. This much delay you are supposed to generate. Okay. Then what is input to the timer? What is input to the timer? This I told already. If you have oscillator, always the oscillator frequency will be divided by 12. And this frequency, this is to timer. This is input to timer. And the oscillator frequency given is 11.0592 MHz. This is given. And you divide this frequency by 12. You will get around 0.92 something MHz. If you convert this frequency into time, the time will be 1.085 microsecond. This you can calculate. Means the duration of one square waveform, the duration of one peak will be 1.085 microsecond. This is clear? Or I can say, if we load any value into the timer register, every 1.085 microsecond, the value stored in the timer register will get increment by 1. Say if you start timer value is 0, then this value becomes 1 after 1.085 microsecond. Then it becomes 2 after 1.085 microsecond. And because the oscillator frequency is 11.059 MHz. So you know output, that is the required time is 0.1 second, and the input to the timer is 1.085 microsecond. And this will be, you convert second to microsecond, you will get 9216. This is nothing but count. Can you understand what is count? The count is nothing but if timer counts 9216 pulse, the timer can able to generate 0.01 second delay, because the input to the timer is 1.085 microsecond. You multiply these two, you will get this 0.01 second, and this is nothing but the time. If timer counts 9216 pulse, 9216 oscillator pulse. This is oscillator pulse. It can able to generate this much delay. This is given. Yes, if you have doubt, you can ask. And we are going to use mode 1. In mode 1, the timer becomes 16-bit timer. So it takes 2 power 16 clock, that is 64K. If you start timer from 0, after 64K clock pulse only the timer will overflow. But as per our calculation, we need only 9216. Means after 9216 clock pulse, our timer should overflow. Then what is initial value? How to calculate? What is maximum value in this mode? This is nothing but FF. Then again we should apply one more pulse for overflow. If you subtract 9216, this is decimal, this is hexadecimal. Better you write this number in decimal, 65535 plus 1. This is the total pulse required to overflow the timer. But if you start timer from 0, the timer will take this many clock pulses to overflow. But we don't want that. As per our calculation, our timer should overflow. Means our timer has to count only 9216 pulse. After 9216 pulse, the timer should overflow. Then what is initial value? How to calculate? You subtract this number from maximum. Then this number will be around 56,320 in decimal. Convert this number into hexadecimal because finally we are going to feed hexadecimal value, and this number will be DCW0. If we load DCW0 into the timer register, then the timer will go to overflow. What is meant by overflow? It will go to FFFF. Then in the next clock pulse, it will try to load 000. These things happens after 9216 clock. It's clear. So we have calculated the initial value. The initial value is DC00. This we note down. Then what is step 3? We have configured a T-mode register. We have identified the initial value. The remaining things are simple programs. Start timer, wait for overflow, check whether overflow bit is 1, stop it, clear the bit. These points you keep in mind. Then we'll start program now. We'll start program. What is step 1? You should configure T-mode. And we have already configured a T-mode value for this particular problem statement. What is T-mode value? The T-mode value will be 01H. The H is not required because any of the number is 01. But if the number is 10, if you use timer 1 in mode 2, timer 1 in mode 1, then H is important. So it is advisable to use H always. Otherwise you people will simply will forget. So this is step 1. What is step 1? In step 1, we have configured T-mode register. This is done. What is meaning of 01? And again I am repeating, 01 is nothing but timer 0 mode 1. What is step 2? Load initial value. And we have calculated initial value just now. It is DC00, and again this is 116-bit number, and this is low and this is high. So instruction number 2 is move TL0. What is TL0? Timer low register. Timer 0 low register. The value is 00. Any again H is not required, but For vector practice, you write H again. Then what is high register? What is high register value? It is DCH. So in step 2 and 3, you are trying to load DC00 into timer register. Because if you load this number, then only the timer will go to overflow after 9 to 16 clock. The duration of 9 to 16 clock will be 0.01 second as per our calculation. Yes, okay. Then step 3. What is step 3? Say in 8051, use semicolon. This is nothing but after semicolon, you can write any comments. Say this is initial value. I'll write. Step 3, you can start timer. How to start timer? There is a bit, there is a register is called a TCON. In TCON, there is a bit is called a TR0, because we are using timer 0. If the bit is 1, then timer will start. Good. And again, this register is bit addressable register. Say using bits, we can start. Set bit. SETB is nothing but set bit. And which bit we are going to start? TR0. And this is nothing but start timer. See, only here the timer will start. And so far here you are loading the initial values. You are configuring, you are loading initial value, nothing else. You have not done anything. But here you are starting timer. Means you already loaded some value, the timer register, that is DC00. When you start timer 0, so oscillator TCON will generate some frequency. The duration of one clock is 1.085 microsecond. Every 1.085 microsecond, the value stored in the timer register will get increment by 1, 0, 1, 2, like this. And again, it takes some time. How much time it takes? According to our calculation, it takes 0.01 second time. And how microcontroller knows whether the timer has reached overflow or not? With the help of the bit is called TF0. Say, what is TF0? There is a bit is called TF0 in TCON register. Normally the bit is 0. It becomes 1 when timer overflows. This bit indicates whether the timer has reached overflow. And what is this instruction? Say here I'll write wait for overflow. So this instruction keep monitors the TF0 bit. Every clock pulse, when you start the timer, in every clock pulse, the TF0 bit will be monitored. What is the instruction? This instruction is jump if the bit is not set. By default, the bit is 0. And if the bit is not set, go to L. L is here only. So you keep monitor the bit TF0 until it becomes 1. So this becomes 1. When the bit becomes 1, it means it indicates the timer has reached maximum, that is overflow. When the bit is 1, it gives a signal that the timer has generated the required amount of delay. Then immediately you should stop the timer. How to stop the timer? By clearing the bit TR0, you can stop the timer. And again, I told already, the TF0 bit, once the bit is set, it remains set, you have to clear it. The program, you have to clear it. So write clear TF0. So now you are clearing overflow bit equal to 0. So if you don't use this instruction, if you don't write this instruction, it is not possible to repeat your program, because once the bit is set, then again if you go and reload the initial value, the controller assumes again that the timer has already reached overflow, then you will not get the required delay. So this instruction is very important. Stop the timer immediately. Say this is nothing but the stop timer. and clear the overflow bit. Then next step, on which pin you are going to generate a square wave P 1.1. So you complement P 1.1. Say what it do is, say upon reset all pin values are set to 1 and it remains 1. How many clock pulses? 9 to 16 clock. Because 9 to 16 we have calculated. The duration of one clock is 1.085 microsecond. So 9 to 16 into 1.085 microsecond. This will be 0.01 second delay. And again, if you write instruction complement, then the 1 becomes 0. Then you are using mode 1. Mode 1 is not auto reload mode. When timer overflows, then from the second iteration, the timer will start from 0. But we don't want this 0 for our application. We should start timer from DC00. Then only we will get the required delay. Then reload the initial value is highly required. Then how to reload the initial value? Then I'm using the instruction. It's called sjump. Sjump is nothing but short jump to L1. Where is L1? The L1 should be here. So again I'm going back to L1. What is L1? In L1 again I am loading DC00 into the timer register. So after overflow, the timer register value will be 000, and just I am overwriting 000 by writing DC00. Then again I am starting timer. So once you start timer, then again the overflow bit will be 0 and again it goes to 1 after 9 to 16 clock. And again once the overflow bit is set, stop timer, clear the overflow bit, then you complement. So this 0 becomes 1 and again this action repeats infinite times. Then in the output window, if you see the output window, you will get infinite square waveform, something like this. And if you measure the frequency will be, this will be not exactly 50 Hz, you will get close to 50 Hz because I'll tell you, to execute these instructions, controller takes some time. If you ignore those time, then only you will get 50 Hz. Practically you will not get 50 Hz. Practically you will get around 49.9 Hertz something. Okay. And this time will be 0.02 second. And this is the timer program. And if you go through the program, if you have any doubt, you can ask me. And this is the fundamental, very, very fundamental program. You can learn other programs easily. Okay, now the task 2. I'll give one more task. You complete the task, write a program to generate, say, 100 Hertz square wave on P1.1. Use timer 1 in mode 1. Assume XTAL is 60 megahertz. So this is problem number 2. See the question, and again the question is the generation of square waveform, but the frequency is different. But now you are using mode 1, timer 1 in mode 1, and your frequency also will be different. I'll tell you the test outline, then you just go through the program. You go through the outline and again you write your own program. And here the things to remember is oscillator frequency is 16 megahertz. This is oscillator frequency, and if you don't forget, whatever may be the oscillator frequency, this will be divided by 12, and 16 megahertz by 12. This will be 1.33 megahertz. This is frequency. Then again you convert to time. Time is nothing but 1 by f. 1 by 1.33 megahertz will be 0.75 microsecond. So what I like to say is, so in the previous problem, the assumed oscillator frequency is 1.085 microsecond, and the duration of each waveform is 1.085 microsecond. But here we assume the oscillator frequency is 16 megahertz, and the duration of one pulse will be 0.75 microseconds. So this is input to time. Then you are going to generate the square waveform, and this frequency is given. Then remaining things are same as the previous question, and this frequency must be 100 hertz. 1 upon 100 hertz is the time, is nothing but 0.01 second. So the duration of one pulse is 0.01 second, and again divide by 2, this will be 0.005 second on P1.1. If you complement P1.1 every 0.005 second, then you will get 100 hertz. So output is 0.005 second by 0.75 microsecond, and you identify, and you still we are using mode 1, but this time we are using timer 1. So what is T mod value? Again, gate is T bar M1 M0 gate C bar M1 M0. This is for T0. These 4 bits are don't care. Gate is 0. Timer mode 1. So now this time this will be 10H, and the program remains same. You calculate initial value will be different, and the T mod value will be different. Instead of using TL0 and TH0, use TL1 and TH1, and remaining all are same. So this task you complete, and we'll discuss in next class.